The isotope 119SN disintegrates according to the function A equals A sub 0 times e raised to the negative 0.0028t, where t is the time in days. A. How much of a 300-gram sample remains after 500 days? B. What is the half-life of this isotope 119SN? So A, how much of a 300-gram sample remains after 500 days? We'll simply substitute 500 in for T. So, and also we'll substitute 300 into the initial amount, A sub 0. So what is A when A sub 0 is 300 times E raised to the negative 0.0028 times 500? And we number crunch on our calculator, and we will get approximately 74 grams. So there's our answer for A. B, what's the half-life of this isotope? So we'll start with the formula A equals A sub 0 times e to the negative 0.0028t. And we want to solve this for t. We want to know how many days does it take in order for these two quantities to have the relationship of 1/2. So A sub 0 is the initial amount. A is the amount that's half of A sub 0. So we can choose, again, you choose the 300 grams that we had earlier. We want to know how many days need to go by in order to make 300 grams equal to half that amount, or equal to 150. So we have e to the negative 0.0028t. We'll divide both sides by 300, giving us 0.5 on the left, equal to e raised to the negative 0.0028t power. To get t out of the exponent position, we'll take the natural log of both sides. So the natural log of 0.5 equals the natural log of e raised to the negative 0.0028t power. And on the right hand side, the natural log and the e exponential function are inverses of one another, so they pretty much divide each other out, and we're left with negative 0.0028t. And then to solve for t, we'll simply divide both sides by our decimal. So the natural log of 0.5 divided by negative 0.0028 is equal to t. And when we number crunch that on our calculator, t is approximately equal to 247.6 days.